Okay, here we go. So this is our next notes in Chapter 9 for circles. And this is going to be Lesson 9.4, and it's on inscribed angles. And you can see the definition here of an inscribed angle. It says an angle that has a vertex on the circle and sides that contain chords. And we look at that vertex on the circle right here. There's your vertex where the angle's formed. And then we have the sides are made up of chords. So chord AB and chord AC. Okay. And so that's kind of our inscribed angle. And a little bit different than the other angles we've been looking at, because the other angles would have the side would be part of the radius, and then it would go off from the radius in another direction, and then that would be our angle with the center serving as a vertex. Here, the vertex now goes right on the circle. Okay. Going with an inscribed angle is something called an intercepted arc. And that arc refers to this thing right here. So an intercepted arc is this right here. Okay. And this refers to an arc that has endpoints on the sides of an inscribed angle. Okay. So these are your sides, and these are our endpoints, right? Here's inscribed angle side, and our endpoints for the arc are right there. Okay. And it lies in the interior of the angle. So this is going to be our arc right here. Okay. And for this one, we just say for triangle Q, the arc BC, it would be a minor arc. It's less than 180. And it's intercepted by angle BAC. So we could just describe it. So and there's also three ways as well that an angle can be inscribed. It can be center on a side. So again, we have the vertex on the circle, but then we have one of the sides running through the center. Another way, the center is in the interior, so kind of like the one we looked at here. The center in the middle of the interior. And then we can also have like this here, this inscribed angle, but the center is on the exterior. So those are really the three possibilities we have that you might see. Okay. And there's a theorem that goes along with this, and it says this. It says if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. So like if we went back at this, let's look at this one, the original one. So this angle here, we'll just call it theta, which would be a radian. We'll just call it theta. So this would say whatever the measure of this arc, right? If you look at this, so then the measure of the angle equals 1/2 the measure of its intercepted arc. So here's the intercepted arc. Okay. The angle equals 1/2 the measure of that arc. So if this was 9, let's just say 60 degrees, okay, the length or whatever, the angle, then we would know that this would be 30, okay, like that. Or if it was the other way, so if we knew the angle was 30, we would know then the arc is twice as much. It's 60. Okay. So if we look at a few examples here, we have this one here says we have some inscribed angles. We have this one MPN, and then we have PNO. And again, we're going to remember this theorem right here. It says find the measure of the angle P. So this one right here. We know that this is 70, so it should be, this is half. It's 35 degrees for P. And then this one, what is the measure of this inscribed angle? PO. We know the angle is 56, so it should be 56 times 2, which would be 112 degrees. Okay, so that's an example of how that works. If we then look at a little bit of a different example here, a little bit more difficult one. And we look at this one. So we have some different inscribed angles. We have one right here, right? And some other ones. And this one wants us to find the measure of arc CF right here. Maybe that's kind of hard to see, but if you look at it, this is the inscribed angle, right? And if this is 40, this should be twice as much. So it should be 80, right? And then we want to do the measure of the angle C. And again, we might get hung up looking at this square and trying to figure, well, this is 90, blah, blah, blah. Don't worry about that, because you just want to remember the rule we just looked at. This is an inscribed angle right here, right? We know what the arc is. It's 98. This should be half, right? So this should end up being 49 degrees, right? So we take 49 times 2, it's going to be 98. So that's 49, that's 80. Let's keep going. So we can also think about angles of inscribed polygons as well. And here's an example. We have this rule for this as well. And this one says, an inscribed angle of a triangle intercepts a diameter of a semicircle if and only if the angle is a right angle. Okay, so this kind of tells us, if we're looking at this thing here, that, and this is intercepting this, if an inscribed angle of a triangle intercepts a diameter of a semicircle, so it's intercepting right there, right? The only way that can happen is if this is a right angle. Okay, and then we can use that to help us figure some things out, because if we knew what this arc was, right, we could then figure out what this angle is, and then we'd know this angle, and we could use Pythagorean theorem and figure out what that angle is, right? So let's look at an example of that. So this one here says, we have this little circle here, we have this inscribed angle, and again it's right on that center point, right, the diameter. So this one says if FJH, that would be, where's J? Let's be J down here. FJH, right there, is a semicircle, there, so it's cutting in half, then the measure of angle G equals 90, right? So this must be a 90 right here. Okay. Or if the measure of angle G is 90, then FJH is a semicircle. So we're kind of looking at this, right? But we can also use this idea to figure out some things that we don't know. And here we see on this one, this angle is called 4x plus 2, and this angle is called 9x minus 3, and this one is 90. But we know when we add them all together, it's a semicircle, so we can just kind of lay this out. 4x plus 2 plus 9x minus 3 plus 90 equals 180. Right, so we have that. So then we can kind of collect like terms. Looks like we have 13x plus, looks like this would be 87, it'd be 89, equals 180. Then we're going to minus our 89 here. It's going to give us 13x. Then if I get my calculator, hold on. So if I get that out, and I do, I wish I would do this in my head, but I can't anymore as well as I used to. So 180 minus 89 gives us 91. Then divide by 13 gives us 7. So x is 7. So then we can just plug it in and figure out what these angles are. So we look at this angle. We go 9 times 7 is 63 minus 3. So this should be 60 degrees. And I could know that this should be 30 over here. Let's check it though. 7 times 4 is 28 plus 2 is 30 degrees. So I figured that out using this inscribed angle theorem. Let's keep going. Last thing to look at is inscribed quadrilaterals, and kind of similar to what we've already been doing, but another rule to remember. So if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary, and that really means just 180. So if opposite angles L and N, K and M, when we add them together, they equal 180. Well, how does that apply? Let's look. So we can see this one here. We have this inscribed quadrilateral, 4 sides, and we have some angles. This one is 58. Write that better. This one is 3y plus 4. This one is 2y plus 16, and this is 2x. Okay? And it wants to know what is x equal to, right? So we can, and what is y, right? Let's just do y as well. So what is y equal to as well? So then we can solve for both, right? Because we know that we add these two angles together, right? Because they're opposites. They equal 180. So if we just do that, 3y plus 4 plus 2y plus 16 equals 180. Collect like terms. We got 5y. And then we got plus 20 equals 180. We're going to minus 20. It's going to give us 160. Divide by 5. And it's going to give us 32. So x or y is 32. We then come back, plug that in. 32 for this one, 32 times 2 is 64. That looks like that's 80 degrees. We go up here, it should be the same. 32 times 3. 32 times 3 is, why is that? Okay, I guess they're not. I'm sorry, I'm sick of this saying they're not. They just need to equal 180, right? So if they need to equal 180, we don't have to do the math, really, because we know this one should be 100, right? But if we do the math, 32 times 3 is 96 plus 4 is 100 degrees, right? So once you figure out one, you kind of know the other one, but you should always check it. So then we have this one. So then we know 58 plus 2x equals 180. But we can kind of think about it because we know 58, so for the x, 58 minus 180, or 180 minus 58, we should probably do that. And then if we do the math, we're going to click on that. That looks like 122 is what's left, right? For this angle should be 122. So then if we just take 61, right? So x equals 61, y equals 32, and then we plug this one in. It should be 122 as well. So that's kind of how you use that. So I hope this all makes sense to you. Add this to your notebook, and you're ready to roll. And I'm going to do some example problems for you as well, so make sure you check those out.